I've added in some fun footage for today, so stay tuned. Lesson number 41 for algebra is rates of change and slope. So a rate of change, definition for it, is a ratio comparing change in one quantity with another. So an example of that would be like distance over time. So let's look at an example of that if it's distance over time. So if the y-axis represents the distance in, say, miles, and the x-axis represents time, let's say in hours. Okay, so if there's 1 hour, you go 60 miles in 1 hour, there's a point for that. And you go in 2 hours, 120 miles. So this shows a linear relationship, and it is a rate of change. So it's distance over time. It's the x value over the y value. So it would, way we can find the rate of the change then would be to go 120 minus 60. Notice I'm on the same axis here. I'm comparing or I'm subtracting the distance from itself. So 120 minus 60, and then 2 hours minus 1 hour. So I'm subtracting the y values over the x values. I think I might have said that wrong. It's the x value, or the y values over the x values. So 120 minus 60 is 60, 2 minus 1 is 1, so 60 miles per hour is the rate of change. So every hour you're getting 60 more miles. So if it was 3 hours, then we could predict it would be 100 plus 60, which would be 180. All right, well this shows rate because it's distance over time. The speed limit was 20, I was going 15, but I sped the footage up so that you could get the whole glimpse of Stadium Way, which is the main road in the center of campus in Pullman. Okay, table for example number 2 has an example for the change in cost over the change in time. So sometimes things get cheaper or more expensive over time. And in this case, so what I'm going to do is I'm going to take $116.50, subtract $60.50, which was from the previous amount. And this is if it was 8 hours versus 4 hours. So 8 hours is the higher rate, 4 hours is the lower rate. So I'm going to subtract that and get $56 for 4 hours. So the rate then would be $14 per hour, and then you can predict what the increments would continue to rise over time for that. So slope, let's go ahead and talk about slope. Slope is basically, it is a rate of change. So what it is rise over run. So what we've been dealing with here is actually a slope of a line as a ratio, and then now looking at it as a slope of a line. So example number 3a gives us a rise of 2 and a run of 4. So that reduces to 1/2. So we would say the slope is 1/2. On example 3b, and you'll have to reference these in your book, is 9 over -3. So the rise is 9 and the run is -3. Okay, so let's look at some definitions for rise over run here. For slope, if it's a positive slope, it rises from the left to the right. If it's a negative slope, it falls from the left to right. You know that a hill is steep when a sidewalk has stairs. Pullman is full of hills, up and down all over the place. This is one of the steepest slopes there is, so I thought I would use it as demonstration. If it is a horizontal slope, it is 0. and you would have y equals c, whatever the constant number is. And then the vertical slope is called undefined. So for example, for A, it was finding that rate of change of slope 4 minus 4 over 6 minus 2. It would give us 0 over 4, so the slope would be 0. So if the y, y would be the constant, would be 4 in that case. So if example for B is 8 minus 4 over 2 minus 2, which is 4 over 0, so that would be called undefined. It would be undefined. This shot is from the top of the library, and it's looking out over the football practice field. So this was a pretty fun lesson to add in slope, because WSU Pullman is full of slopes all over the place.